Okay, so
Because this is still hurting my brain.
all right.
Cool, but it's hurting my brain.
So one thing I wanted to go over really quick is different types of materials. So you've got materials and you've got textures, and a material has a material is going to have several different components to it. It is also a component. So, all right. So, a material can be attached to a game object as a component, and it's going to be used by the mesh renderer to sort of affect the way a surface looks. I can have textures, which a texture is an image file of some resolution, or it could also be a video. And then I have shaders. For today's purposes, we're not going to talk about shaders except to acknowledge their existence. Because a shader is a piece of code that is a part of the material that is the instructions for the video card. It doesn't make any sense. The shader is not going to make any sense to the processor that's compiling the game code. It's a completely different programming language. And it's used. The good thing about shaders is that if I have a shader that I wrote for Unity, I should be able to use it for OpenGL or use it for a bunch of different things because it's a common shader language. It's just a completely different language than what we're using here. And it's the instructions on how to get a graphics card to do different things with the textures and the images and the colors and the blend modes. And I want these things to blend together. All of these things are used by the shaders to determine the look and feel of a particular material. So if I come back over here to Unity, and let's say I've got, where is my moon material? Okay, so I've got my moon material, which right now is an exact duplicate of my default material because I haven't really applied anything to it. I can start putting values in these different slots over here. So I've got Albedo, which is Unity is really weird because it's the only time I've ever seen Albedo used for this. Normally this is called the diffuse color of the material, but Unity likes to use Albedo for some reason. I took an astronomy class once, so I know what Albedo means. But why Unity uses Albedo instead of diffuse or main texture or something like that, I don't know. If you don't know what Albedo means, it's the light that's reflected off of an object. So the moon has a very high albedo because the light that's coming off the surface is very reflective. Different planets have less albedo.
So can you change the value on it like you could with
I absolutely can. So I can give it a texture, right? And then this color over here is still active. It blends the color and the texture together. So if I want to give my moon kind of a rosy pink hue, I can give it a color, and then that color is going to sort of blend together with that texture. Now that's a function of the shader. I could write a shader that uses one or the other. If I give it a texture, it ignores the color. If I don't have a texture, I only use the color in those instances. But that's just the way the shader is written. The standard shader in Unity will blend the two together. And if I don't want a nice rosy pink moon, I guess I can always give it something a little desaturated. Now, these different maps down here, got a metallic map. I can either give it a value over here, one of these parameters, or I can actually give it a map that shows it what parts of my model, what parts of my map do I want to be shiny, what parts do I not want it to be shiny. A normal map defines bumpiness, and in order for that to work, I have to give it a normal map. So I've got another texture down here, and I've got this default it's actually another picture of the moon's surface, but it should work fairly well for a normal map. I can come up to the texture type, define it as a normal map, and hit apply, and now it's going to turn purple. Or it should turn purple. Oh, create from the grayscale. Durr, forgot to check that. Now it turned all sorts of TV noise, staticky purple, because it's turned it into a normal map. A normal map, like you'd see there, or there's another one that came in, a lot of times have this sort of purple hue to it. In a regular bitmap, you've got a red component, you've got a green component, you've got a blue component. And these are values, they could be values between 0 and 1, they could be integers between 0 and 255. It all depends on how they're stored internally in the file. But the red goes into the red channel, the green goes into the green channel, the blue goes into the blue channel. All three of them together work to make one magic color. They form one giant color. Robot colors fighting. Anyway, but I've got three components. What else is made up of three components? A vector. So instead of defining colors, the three values in each pixel of a normal map define a direction vector.
For each point.
For each
in
point.
the map.
For each point in the map. Now, and what that's used for, without getting too deep in the woods, what's going on with the engine is I've got this simulated light, right? And normally, what we call the normal of a surface is perpendicular to that surface. So if light comes in, even simulated light, it's going to look at the normal of that surface and figure out how to shade that surface based off of that direction. Based off the direction of the light and the direction of the normal, I know whether or not I need to put a highlight there, whether I need to put a shadow there, and whether or not I need to put, just regular color. That's all determined by the normals at that surface. Now, if I don't give it a normal map, it's just going to assume a flat surface. But by giving it a normal map, now I can tell it, hey, these parts of this map are supposed to be pointing in this direction. These parts of the map are supposed to be pointing in different directions, and I'm simulating bumpiness on the surface. By overriding the natural normals of whatever smooth surface I have, I'm going to be using this to make my moon a little bumpy.
So you have to tell it the dark is lower, light is higher, whatever at some point.
But that's an assumption. That's an assumption.
You need to do that.
Right. And when I turned this into a normal map and I came up here and said, instead of a texture map, I want this to be a normal map, and it said create from grayscale, that's sort of the assumption that it's making, is that white is the high points and the dark regions are the low points. All right. Then I can take this up and drop it in my normal map. And that's probably a little too normal, so I can come down off of that value. Oh, bump map scale is not supported on mobile platforms. So what I could come over here, I could tell it that I want my normal map to be a lot less bumpy. And watch, these colors are going to change. Then I can come back over here and I can give it a scale of 1, which will make it happy. And now my moon doesn't look all crazy craggy. I've got just enough surface texture, and you can see how it's modifying both the shadows and the highlights across that surface. We didn't used to see these details right in here before that. So we're going to zoom out a little bit from the moon and give the Earth a little give the earth a little attention. And I'm going to put my new material on my earth surface object. I have an earth texture. And an earth normal map. Oh, but they don't match up. Ah, dadgummit. So I can see there's the bumpiness of Baja California and Mexico going right out through the middle of the Gulf. So that's not really going to work.
The lovely mountains of Iowa.
Yeah. Yeah, the Minnesota Rockies are beautiful this time of year.
And still getting snow.
Okay, so maybe that's not going to work. It worked all right for the moon, but I guess I probably grabbed these. So do you understand what's going on? The actual images that I'm using don't match up. The parts of my texture map that represent the United States are several pixels to the left of the pixels that represent the bumpiness on my normal map. Maybe this one will work. I'll turn this one into a bump map and we'll... even worse. So it's my texture map that doesn't line up. No, that really doesn't line up. Okay, so
that looks great. Just go with that. That's cool.
It's pretty neat. So this is one of the screen grabs that I got off of the Null Skull? Skull Null? Skull?
Old school, yeah.
Null Skull. That's... Alright. So that's what I get for not making sure of what I'm working with. I'm actually going to... Oh, another convention that I wanted to mention. Every time you see these little, like the little bullet next to one of these fields, you'll see a little circle with a little dot inside of it. And what that does, if I click on one of those, it'll bring up a chooser. So I could drag a texture over into one of these slots, or I could pick that, and it's going to bring up this this offering of all the textures that are in the project. I can filter out my choices based on the name up here, but none is always an option. Where'd my moon go? There's my moon. Now, clearly this is not to scale. And I probably won't ever get anything but a glimpse of the moon the way this is set up, because there's my camera view. So I'm only going to see the moon when it goes from the edge of the screen to behind the Earth, and then from behind the Earth to the edge of the screen. That's okay. One other thing I wanted to try really quick before we get into the Android Vuforia stuff is, where is my... Let me make sure it's not my... So this is a little video clip that I created while you guys were at lunch. Looks like it's about 7 seconds of stuff, along with my taskbar and Google Chrome window. So what I'm going to try with this, I'm going to add a component called Video Player. I'm going to add this as a video clip. All right. So now what it should do is it should replace whatever I put in the albedo of this texture with this video clip that I've got in this video file. And it took it a second, but it seems to be working. Everything's spinning so fast, but you get the currents moving.
Can you slow the speed down just a bit?
Mm-hmm.
The video fairly slowly.
Oh, the video's not playing at all.
It is.
Is it?
You can see the tracers moving really slow.
Well,
it's surface mode, so it's going to be slow.
I can control the playback speed. Let me see. Loop. There we go. That looks a little better. I mean, look at the stuff coming off Australia down there.
Yeah.
So I got this black seam here because I didn't accurately capture the full extent of that frame. And I bet if we look at the polar ice cap, it's my Chrome window.
That's awesome. Can you click on the bookmark over Greenland?
Well, look, see, oh, there's my taskbar down there at the bottom.
That's pretty cool.
So, if I wanted to go through the effort, I could probably mask that out in something like Adobe Premiere. I didn't really feel that. There's a volcano going on down there right now. So that works fairly well.
That looks cool.
It does look cool.
What format did you save the video in? And does it really matter?
It does matter. I saved it as an MP4.
So you pre-encoded it?
Yeah.
With what you saved?
Yeah.
Okay.
And I used a piece of software called open broadcast software. In fact, it's the same thing I'm recording this with.
Open broadcast?
Yeah, OBS. It's free and it's really amazing stuff. I like it a lot better than Adobe Connect, especially for like recording these sorts of sessions. Because what it can do that Adobe Connect can't do is it can record both of these screens. And if you notice what it's doing, there's a little confidence monitor. I come over here and I touch this one, and it changes. I come over here and touch Unity, and it changes back and forth. So it's constantly recording everything and cycling back and forth automatically. I love it. Yeah, and I just used OBS. I went to Null School. I'll never get that straight. Null School, and then just played it full screen and recorded that desktop while it played. Easy peasy lemon squeezy.
And you said that's free?
Do what?
That's free?
It is.
Nice.
Free and open source.
Beautiful.
I'm all about free and open source.